Man, I've been really looking forward to this conversation with you. I think we've been chatting now for a few months, back and forth, and yeah, I was really excited because I love geeking out about this stuff, and like I actually found you just in the search engine on YouTube, just the physics of archery, just because I was curious. As bow hunters, you know, we all shoot from tree stands. There's different effects if we're shooting on an elevated position or shooting uphill. Our arrows and our aiming points have different effects. Front of center is like this huge topic in the archery world. You know, there's just so much more than that goes into archery and bow hunting than we know. Front of center, center of mass. Momentum and energy, all this stuff, and it all plays down to Newton's laws. Now, I didn't even make it through high school, so I am nowhere near, I understand this stuff, but like your videos, I think I watched 3 times, and I probably have to watch them 10 times to get a full grasp on what was going on. And still then, because like you're a professor, how long have you been doing what you do?
Let's see. Um, well, I've been teaching at the collegiate level for let's see. I'm in my eighth year where I am currently at Montreat College, and I taught chemistry at Virginia Tech for something like 8 years before that. So let's call it 15 years of teaching at the collegiate level at this point.
Yeah, so a lot, and obviously before that you must have done some education yourself, obviously, and obviously going through high school and all that. It must have caught your attention, all this stuff.
Yeah, I'm just get out of the way what I am. I'm a chemist. So before anyone gets too mixed up on things, I finished my PhD work at Virginia Tech in chemistry. I'm a physical chemist, so that means that basically I'm interested in physics. I'm interested in the physics of atoms and molecules. So I teach chemistry. I've taught chemistry, organic chemistry, physical chemistry, but I also teach physics at my institution. And yeah, so I've been doing it for a while, the undergraduate, graduate, all that kind of stuff. My formal education probably tends more on the side of quantum mechanics and particularly thermodynamics, neither of which are of particular interest to archers and shouldn't be because we don't need those things to describe an archery system. So it took me a little while actually when I first started getting into this stuff to sort of wrap my head around sort of the more classical mechanics type things that I put videos together on that you referenced on YouTube. So that yeah, I've been doing it a while.
Yeah, and I'll put so just for the listeners, scroll down. You're gonna see a YouTube link. Just click on that if you want to watch um, Jared's videos after this. Now, Newton's laws, like I'm sure at some point in time, every listener has heard for every action, there's an equal and opposite reaction. Now that's important stuff, but I didn't realize that there was other laws of Newton's as well, and these play a big part into archery. And archery is bow hunting and all that stuff. And what we talk about on this podcast is archery specific stuff. But there's a lot of stuff in here, like I was saying earlier. There's highly heavily debated aspects of archery. Front of center is always debated. But I thought when I first found your stuff, I thought it was really interesting because it really explains why things happen the way they do when we're shooting. There's a lot of times that you just have zero, you shoot an arrow or you're hunting or you're at the archery range and things happen and you have no idea why they're happening. So I found it really interesting going through your stuff. So I don't really know what the best way to start this is. My plan is we're gonna pop this out in a couple parts. Now, if we need more time, I'm not sure how busy you are, but by all means, if you feel, I would rather us do these podcasts over if we have to, over, some multiple times, some multiple spaces.
Yeah.
So by all means, please don't feel that we're on a timeline. We can, I could put out 3 episodes now, and then in 6 months from now, if we have to get back into it to finish it off, we can finish it off then. So
Well,
what do
if
you
you have any
think?
listeners that have follow-up questions or things that they'd like to hear about, then we can compile those and talk about them later. That would be good too.
Yeah, absolutely. So, why don't we just start out with, explaining a little bit. Well, I'll let you take over because like I said, you know, I'm nowhere near qualified to talk about this. I love listening to this stuff and I'm super fascinated of how it applies to archery and bow hunting, but maybe if you want to just take it from here, and I'm going to try really hard now. One of the things I know my listeners will agree with is that I have a tendency to stop people in the middle of their tracks and try to get what they're explaining. I'm not going to do that with you. Number one is because we'll never get anywhere if I do. So the nice thing about this platform and this, listening to it on a podcast is for the listeners and myself, you can always go back, rewind it if you miss something or if you're not sure or if you didn't catch the whole thing or you can listen to it multiple times like I've done with your YouTube channel. So why don't you just start off what you think is kind of relevant and then we'll just take it from there and we'll kind of work it into like how it applies to bow hunting. And like in your video, you have a really interesting you got a really interesting chapter there on bow hunting specific stuff and how all this plays into bow hunting, like penetration, arrow flight, all that stuff. So we can kind of lead it up to there. But I mean, there's just so much stuff of like motion, you know, uh, linear motion in your thing. You talk about vectors and scalars, velocity, acceleration, gravity. Gravity plays a huge part in aeroflight. And it's all just super fascinating. I think there's a lot of listeners, a lot of the geeks out there like myself that are going to love this information. So I'm just basically going to hand it over to you and
Okay.
let you roll.
So I guess we should go back to where this started for me when
Hmm.
it came to archery. So I I grew up. I was not a hunter growing up. My family was I grew up very rural in southern Virginia, southwestern Virginia, and my dad was not into hunting. We were into processing. So around every Thanksgiving, I can remember growing up having deer brought to us by friends and neighbors, and we would process it and can it and all that kind of stuff. And that's what I lived on a lot growing up. But I never actually did a lot of hunting as a young person. And as I got older and had kids, my kids started hunting with my father-in-law, their grandfather. And I was like, well, I kind of want to get into this. It was something that had always interested in me. I just didn't really do it. And I wanted to do it with archery. So, by the way, I still don't consider myself a hunter. I'm someone who enjoys going hunting every once in a while. Unfortunately, because my job is teaching is gets to its highest point right in the middle of hunting season here. I just don't get to do it very often. But nevertheless, I wanted to do archery, and so I got into archery, and this was 10 years ago or so now. And one of the first places that I started going for information, particularly about bow models and all that kind of stuff, was Archery Talk. So Archery Talk was big at the time, probably still is. I don't know.
Still
I
is,
don't
yeah.
see it very
Yeah.
often anymore. And if for someone who's interested in physics, it takes about 5 minutes of being on Archery Talk, or at least it did at the time, to find someone arguing about physics in hunting.
I was just
Um,
gonna say the one thing about archery talk is like and this is true in any archery discussion. There's a lot of opinions in archery. And I know when it comes to like and I've geeked out on this stuff and I've read all the this when you get into the physics of archery and like it's funny and like there's seems like there's a lot of misconceptions in there and like a lot of like bad information where guys are like even I know that can't be true, right? Like I don't
yeah,
know the
yeah.
equations to get there or anything, but I just know that that can't be true.
Well, and that's kind of exactly where I was, because like the very first thing I think I ran across was momentum versus energy. And So as someone who's understands or who's spent a lot of time thinking about physics, I that immediately struck me as weird. And so I started reading up, and there was these big arguments about what's more important. What's more important? Is it energy? What's more important? Is it momentum? And there are lots of people who are on either side of that equation. And what's really struck me as strange is, uh, well, most of you or most of your listeners, certainly anyone who's interested in physics and archery, have probably heard the quote definition of kinetic energy, that it's one half mass times velocity squared. And so you'll always hear people talk about, well, the kinetic energy has to do with velocity squared, and the momentum has to do with velocity, because it's mass times velocity, and those two things are why one's better than the other, and you get all these kinds of weird arguments. But one of the things that you'll find very quickly if you actually study physics is that kinetic energy and momentum are very closely related to each other. So everyone's used to one half mv squared is kinetic energy, but there's an alternative definition that is momentum squared divided by twice the mass is also the kinetic energy. So when you think about things from that standpoint, if you say, well, is it momentum or is it energy? When I first saw that, I was like, that seems weird, because I know that if I have the momentum, I know what the energy is. They're sort of telling you the same thing. And so why is there this big debate? And so again, it took me a little while to sort of wrap my head around where people were coming from. And what I realized is that most people arguing for momentum versus kinetic energy were actually arguing for heavy arrows versus faster arrows.
Hmm.
And those four things actually aren't the same. So that's kind of where I really dove into trying to put together these videos, the videos that you're referencing. And I do encourage people to go look at them if you're actually really interested in physics. They're long. Basically, they are a short course on what would be first semester general physics, where the examples used are archery examples. I mean, that's really what those videos are. It's
Yeah,
less
they're awesome.
specifically about archery and more, here's how physics works, and we're going to use archery as an example to demonstrate the things that work in physics, whether they're Newton's laws or kinetic energy, work energy theorems, all that kind of stuff. So that's all in there. But the biggest thing that I really wanted to try to get to the heart of was, where was this mistake being made between momentum, mass, kinetic energy, and speed, velocity? So that's basically was my starting point. And I really think that to really understand what's going on with the physics, particularly with respect to bow hunting, you have to have a good understanding of what each of those things are and what each of those things tell you. So I guess we could go into those now, or
Yeah.
if questions. You said you weren't going to jump in and interrupt me, but actually, with my students, I encourage questions, because I think that questions help me make sure that I'm going in the right direction to make sure people understand what's going on. So, do you have any before I kind of jump into the spiel?
Well, I mean, I do have questions, but we're gonna get into all these. So why don't we just start with like, well, why don't we just start? We could just start wherever you want. But I was hoping we can get into like just kind of start from the beginning, and then we'll kind of work it into like bow hunting, like you did in your. We don't have to obviously go that long because they go into great depth and detail. And I really do encourage people to go scroll down, click on that link, and you're gonna have to do it when you have some time. You know, don't do it while you're driving. Make sure you got a bit of time in front of your TV. Watch it on your TV. It's super fascinating. But why don't we just start off with like motion?
Yeah. Okay. It's good. So obviously the correct place to start. It's where any class in physics is going to start, because you have to know what you mean by motion. So
Mhm.
what do we mean by motion? And to do that, you have to sort of think about how things are moving, and what perspective you want to take on how things are moving. So it's sort of implicit, and I think that this is the normal way of thinking about things for someone who's doing archery, and it's a good way of thinking about it. But you do have to understand what you're actually doing. You have to choose your reference point. You have to choose your frame. How am I going to describe what's going on? Am I going to be sort of on the arrow as the arrow is moving? Am I going to be at the animal with the arrow coming towards me, or I'm going to be at the point of the archer and watching the arrow leave? And so, in most cases, it makes the most sense to sort of choose your frame to be centered on the archer, and that's what's most logical sense. And so, we want to talk about describing the motion, describing what the motion of the arrow is. So that's this idea of velocity. So, velocity is a description of how the arrow is moving. Before you fire the arrow has zero velocity in the frame where you're measuring things relative to the archer. And then after you fire the arrow, of course, the arrow has some velocity. And the velocity is one of these vector quantities, which basically just means that you can't describe velocity with one number. You can't say the velocity of this arrow is 10 feet per second. Well, that would be pretty slow, wouldn't it? 180 feet per second, or whatever it happens to be. You have to define both the direction and a magnitude of velocity, which is what we call the speed. So velocity is really a way of putting labels on the exact motion of the thing that you're studying. In this case, we're studying an arrow, and we want to know its velocity. That's what the velocity is. It's a description of the motion. And it does have this vector sort of quality to it that the arrow is flying in this direction with this much speed. And you combine those two things together to form the velocity. That's the basic idea. So then the question became for me, and this is where I had to wrap my head around thinking about things a little bit differently. Is the velocity something that we control as an archer, or is it something the result of other choices that we make? So in physics, like if you go and you just sit down and do a physics class, we'll often think about velocity as being the control parameter. In other words, you imagine like the classic example that we might do for projectile motion in a classroom is that you're standing on a cliff, the edge of a cliff, and you fire a cannonball, and you say, okay, initially the velocity of the cannonball is, well, it's 30 degrees above the horizontal. That's the direction it's pointed, and it's moving at 250 meters per second. So you define the velocity, and then you sort of figure out everything else by starting with the velocity. So you think of the velocity as being the thing that you control, and then other things like the energy of the projectile as being the things that are the result of the velocity. And I think that's how most archers tend to think about velocity and energy and momentum, is that you start with velocity and you can calculate 1/2 times the mass of my arrow times whatever the speed of this arrow is. That's going to tell me my kinetic energy. So my kinetic energy depends on my velocity. And then the momentum is the mass times the velocity. So my momentum depends on my velocity. And that was what was in my head when I first started thinking about archery. And that turns out to be wrong. That turns out to be not the right way to think about things, because we actually don't have a velocity selector in archery. When this is probably everyone who's had a little bit of experience with purchasing compound bows knows this, right? You know, you look at you look at your manufacturer, and if you want to see how quote fast a bow is, whatever I don't know what the speeds. I don't do compound archery anymore.
Yeah, well, like an IBO speed
I
for
think
like
typically what 335,
yep,
340 IBO speed, something like that.
yep.
That's kind of average, right?
hmm
And so a lot of times you'll see this on forums. You'll have someone new come in, and they'll say, "Oh, I've got this new bow. It's supposed to shoot arrows at 335 feet per second, but my arrow is only going 285 feet per second. Why is that? What's wrong with my bow? Why is my bow broken?" And you go, No. That's an IBO spec. You have to have 5 grains per pound of draw weight. You can't have anything on the strings.
Hmm.
All kinds of things go into actually getting that number. So anyone with some experience knows that about a bow, and that's because the bow doesn't shoot at a specific speed. The bow has a certain amount of energy stored in it, and it delivers a certain amount of energy to the arrow. So the bow actually, what you select when you're selecting a bow is how much energy the arrow has. And so the speed is not something that you have direct control over. What you have direct control over, technically, what you have direct control over is how much energy you put into the bow when it's drawn,
Hmm.
right? So you know that the bow has a certain draw length associated with it, and you could look at the draw force curve to see what the curve looks like. And it turns out that those two things tell you how much potential energy you put into the bow. So what the bow does essentially is it converts the stored chemical potential energy in your body into stored potential energy in the bow itself at full draw. And then it takes a portion of that potential energy and converts that into the kinetic energy of the arrow. So the bow is actually going to give you a certain amount of kinetic energy in your arrow. Now, the amount of kinetic energy that the arrow has from the bow is going to vary slightly depending on arrow mass. You'll hear people say this all the time: the heavier the arrow is, the more efficient the bow is. And what that means is that the energy you're putting into that bow to draw it, not all of it actually goes into the arrow. Some of it goes into making noise. So there's some sound when the bow is fired. There's also some heat generated. You probably wouldn't ever really notice this on firing a bow, but there's friction
Hmm.
associated with it. There's friction associated with the cams turning over. There's
Makes
friction
sense.
in various other different places, and so it generates some heat. There's energy losses, and so that sort of takes the total energy that you put into the bow to draw it. Only a percentage of that actually ends up in the arrow. Only a percentage of that actually ends up in the arrow. But the important thing is the bow is not firing it at a particular speed. It's firing with a particular amount of energy.
Right.
So what does that mean? I think that means that it's very easy to get caught up in equations like 1/2 mv squared is equal to the kinetic energy. And we tend to, or people who are not familiar really with physics tends to look at that and say the kinetic energy is defined by the velocity. But you could take that equation and rearrange it and solve it for velocity instead of having kinetic energy. You end up with what is that? Twice the kinetic energy divided by the mass, take the square root of that, and that's equal to the speed. So you can rearrange that equation and say, no, what I actually have is I start off with a certain amount of kinetic energy and I start off with a certain mass arrow. And once I have those two things, that tells me how fast my arrow is going to go, which
Right.
is intuitive to an archer. Like if you're not thinking about the equations, if you're not thinking about physics at all, if I ask you, how do I get an arrow that's going to go 280 feet per second? Then you, if you were setting me up in a bow, you would say, okay, all right, tell me about your bow. First of all, is the bow that you're using even capable of firing an arrow at 280 feet per second?
Right.
You're not going to get a 35-pound compound bow meant for a 9-year-old with a whatever it is a 17-inch draw length. It is just not going to be able to shoot an arrow at that speed, at least not an arrow that weighs enough not to blow the bow up,
Yeah.
right? So you know that you have to select your bow first, and then you have to select your arrow. And what you're selecting with your arrow, you're selecting essentially how heavy the arrow is. The
Hmm.
heavier the arrow is, the slower it's going to be. The lighter the arrow is, the faster it's going to be. You have to take the combination of the bow, which is energy, and you have to take the combination of the arrow, which is mass, and those two things together give you the velocity. So
Right.
you don't have you can't just look at there's not sort of some control knob in your system where you can independently just turn that one knob and it makes things go faster.
I'm sure
You
there'd be a
have
lot of
to have
guys that like that though.
what's that?
I'm sure there's a handful out there of guys listening or gals listening that would just love that if they could do it
Yeah,
because
yeah, yeah,
like
yeah, yeah, yeah,
that
yeah, yeah, yeah,
that's a
yeah.
big, you know, guys who have really long draw lengths, they're, uh, guys who don't, they're envious of those guys that do because like you were explaining, that would explain why the longer the draw length, the
Yeah,
faster the arrow's going.
you just get more energy. You store
Yeah.
more energy in the bow the further you draw it back.
Yeah.
And that's for a given bow. I mean, this is, you know, if you go to a traditional archery, which is what I'm more do more myself now, it's the same thing. You don't have a draw stop, so you don't have the
Hmm.
bow set to a particular draw length, but it's just basically how far are you going to draw that bow back. The further you draw it back, the more energy there is in the bow, and the more energy that there is in the bow for a given arrow, the faster the arrow goes,
Hmm.
right? So I think that's the important thing for me, was because we tend to think about things, these arguments online tend to start with velocity, and then calculate the kinetic energy from that. And I think the better way of thinking about it, the correct way of thinking about it, is the kinetic energy is a parameter that is principally determined by your choice of bow, and then the mass of the object is completely determined by your choice of arrow, obviously.
Hmm.
And then those two things together are what give you velocity and momentum. Momentum and velocity are what I would call, for an archer, I would call those dependent variables,
Hmm.
meaning that I don't have immediate direct control over either of those things. What I have immediate control over is kinetic energy by my choice of bow, and arrow mass by my choice of arrow.
Hmm.
And those are the things I would call independent variables. I can choose those however I want to. I can make
Hmm.
any combination that I want to. If I pick a poor combination, the bow might blow up. But you know, in principle, I can choose either of those in any combination that I want to. And then from those, I'm going to have a certain velocity, and I'm going to have a certain momentum for my arrow based off of those two things. So I
Yeah.
dropped here. So sorry about that. So that was a lot, but the reason
No,
I
no, and it's really curious, but I mean, like, yeah, like we can manipulate that by choosing, if you got a 27-inch draw length, you could shoot 50 pounds, 60 pounds, 70 pounds. You can shoot a heavier or lighter arrow. You can get into length of arrow. Obviously, the longer the arrow, it's going to affect how it flies. It's going to be heavier, FOC. So a little bit about like vectors and scalars. I really enjoyed this part, just because it does apply to hunting. Like if you're hunting in a tree stand, if you're shooting up top, like I know there's a lot of guys wonder why, how come if I'm standing on an elevated position and I shoot down, why is my arrow hitting in a different spot? And then why is it the same if I shoot up, but it's not the same if I shoot straight?
Yeah, yeah. So those are questions that I would I can give you the way that vectors work. Why the specific answers are what they are. That would be someone who is an archery coach who has actually spent a lot of time talking and thinking about those things would be better suited than me for doing that. But yeah, we've talked about, so vectors versus scalars. Scalars are just numbers.
Hmm.
So scalars are things that in sort of the common way of thinking about them, don't have direction. So for example, you could talk about the temperature of a room. The temperature of the room doesn't have a direction. The temperature isn't pointing in one direction in a room, right? So that's a common thing we would call a scalar. The mass of an arrow is a scalar. Mass is a scalar quantity by definition. The things that are vector quantities are velocity and momentum in when you're thinking about what's applicable to archery. Um, I tell you what, my computer's going to beep at me a lot, so I'm going to change this over to do not disturb, so I don't have my email beeping at us every 2 seconds. Sorry about that.
Oh, good.
Yeah, so certainly you have to use the idea of vectors to think about of what's happening if you're pointing above the horizontal, at the horizontal, and below the horizontal in an archery system. And there's going to be a lot of things going on with what's called projectile motion, which is well, projectile motion is exactly what it sounds like. It's just the motion of a projectile that includes arrows, but it's
Hmm.
basically anything moving in a plane on a parabolic path. And I think that in a lot of cases, the when it comes to shooting out of a tree stand and aiming higher or lower and all that kind of stuff, also has a lot to do with the geometry of your eye and how your sights are set up, and as you hinge, whether or not you're hinging at the waist properly versus sort of
Hmm.
scrunching over,
Yeah,
all that stuff can
definitely.
change the line of sight. And I honestly think that probably has a lot more to do with hitting high or hitting low, if
Hmm.
you're above or below the horizontal, than anything to do with the physics of the arrow flight. Although there could be something there, I'm not sure.
Yeah, it does too. And I mean, third axis on your level because the if you have something on a plane this way, as you tip it, obviously the axis point of that is going to change as
Yeah,
it tips
yeah.
forward or backwards. Um, FOC, center of mass, arrows. W Talk a little bit about that and like how gravity plays such a huge effect on aeroflight.
So all right, so let's take a step back first because I want to just kind of put a bow on the momentum thing that I was getting at a while ago,
Yeah,
and why kinetic energy is, well, it's important to recognize that your choice of bow in principle determines your kinetic energy. Because going back to the original thing, that the debate that I think people still have a lot of for whatever reason, probably in large part because of the Ashby reports, is the idea of momentum versus kinetic energy. And to me, that's not a question. That's not even a reasonable question. Once you recognize that the thing that I have control over is the energy, I don't have direct control over the momentum. So I can't say, well, I need more momentum or I need more kinetic energy. The kinetic energy is the thing that I control. The momentum is the
right,
result. So really
right,
what you're
yeah,
asking is kinetic energy. I've got a certain kinetic energy because this is the bow I'm shooting. Now, is it better that I have a high mass arrow, which will result in a larger momentum, or a low mass arrow, which will result in a smaller momentum? But both of those arrows will roughly have the same amount of kinetic energy.
right,
So I think that it's not a good question to compare kinetic energy to momentum. The question to ask is whether or not you should be using a heavier arrow or not. Assuming you're not going to change your bow, you're set on your bow. I know there's a lot of people that change bows out every year. I'm not.
guilty.
I wasn't big on that when I was shooting a compound, and I certainly don't do that now. Shooting a traditional bow, I've had the same bow for many years now. So the question then becomes, how heavy of an arrow do I need? And the trade off is obviously the higher the mass, the momentum I'm going to have, but the smaller velocity I'm going to have.
Hmm.
And my arrow will be slower, and you get, here's where your idea of gravity playing a role is going to be important. So in projectile motion, if you're talking about gravity and what's going on with an arrow, gravity is a force. So it's actually, so we call it weight in physics, and it's just mass times g, which is the constant for gravitational acceleration. So g is represents the force of gravity. Close to the surface of the Earth, it's about 9.8 meters per second squared. That's like 32.2 feet per second squared. And it points this way. It points down, right? So as your arrow is moving, it's the way that the arrow is in motion, its velocity, that changes following Newton's laws. So we had mentioned this a little bit earlier. Again, I'm not going to try to describe all of Newton's laws in this podcast. You have to go watch videos on it, whether mine or someone else's. But the basic ideas of Newton's laws tell you the relationship between how the velocities of things change, and the forces that are acting on them. So if you have an arrow and it's got a velocity, I'll use this as an example, or maybe I'll use an arrow as an example. Here we go.
Perfect.
So
Yeah,
you've got your arrow and it's moving in this direction with a certain amount of speed.
yeah.
If there's no force acting on the arrow, and including gravity, if this is just sitting out in space flying with a certain amount of speed, it's going to stay on that trajectory forever. All right, that's Newton's first law. Newton's first law says that if there's no forces acting on this thing, its velocity is not going to change. Okay,
Oh,
its
really?
velocity,
It's not going to lose. eventually lose momentum if it has no
Nope, nope, nope.
exterior outside objects affecting it?
If it has no forces acting on it, it will stay in a state of
Cool.
perpetual motion, which is it's called the law of inertia. It's Newton's first law, and it basically says accelerations in the absence of forces are zero. Acceleration is how fast velocity is changing. So if the velocity is not changing, then it just does what it does forever. Okay, so this is like a piece of rock sitting out in outer space. It's hurtling through space. It'll just keep hurtling through space forever until it hits something. Okay, until some force acts on it, it's just going to keep moving in a direction. Okay, now that piece of rock goes near a planet, and the planet is exerting some gravity on it. That gravity is a force, and what's that going to cause the rock to do? It's going to cause it to change its velocity. It's going to accelerate, and it will start to curve. So as a comet is in orbit around the sun, as it gets closer to the sun, it's going to cause it to swing around, and you get this change in motion, and those changes in motion occur because of because of forces, because of external
Oh,
forces.
okay. Is that why when they go to like they're going to the moon or something, or even like you watch in movies, they always like slingshot. You always hear them talking about
Yeah,
slingshot
yeah.
around the
So
moon or something.
slingshotting around is it has to do with these gravitational forces, and it's a way of actually, interestingly enough, it's a way of stealing momentum from a planet to
That's
increase
so
the
cool.
velocity of the object that's going. Yeah, I was actually watching a documentary on Voyager and some of the other satellites that we've sent out to explore like the moons of Jupiter and things like that. And that's
Yeah.
one of the really cool things that they did is they would send this satellite out. And it would go around the sun and would come back, and then it would slingshot around the Earth, and it would use this sort of gravitational slingshot to get it going fast enough that it could go out to Jupiter and
That's
get
just
to Jupiter's moon.
crazy.
Yeah, in a
Yeah.
shorter amount of time. But the idea is that if you take that thing and you slingshot it, and now it's away from all of the planets, it's just moving, and it gets out of the gravitational field of the sun, or at least enough where the gravity is very minimal, then that thing's just going to go on forever. Okay, and that's Newton's first law. Newton's second law says, well, suppose there are forces like gravity, and so what happens? Okay, so in the case of an arrow in flight, as the arrow is moving, there are only two forces acting on it. There's the gravitational force. The gravitational force acts from the center of mass of the arrow, and it's again pointed straight down. Okay, assuming that we're thinking about shooting at a horizontal thing, it's pointed straight down. So if the arrow is say moving upwards this way, then it's pointed vertically.
And the center of the mass is the air is the point, not the center of the arrow, but the center weight of the arrow, correct?
Yeah, so I'm trying to find it here.
Yeah.
So this is without dropping this thing. This is about the center of mass of this arrow,
Yeah. And as we can
and so the
see,
center
it's
of the arrow is like somewhere back here.
yeah.
And in fact, this term FOC, if people are unfamiliar with it, which means forward of center, it actually is just a measure of how far ahead of the actual center of the arrow the balance
Hmm.
point is. So if this is the actual center of the arrow, just taking the length of the arrow and dividing it in two is there, and then you would see how far ahead is this balance point relative to the center of the arrow. And so the basically all arrows have that that anyone uses has at least 8 to 10%. It's called 8 to 10% FOC, which basically just means, all right, here's the length of my arrow. 1% of the arrow is 100 of this length. So how many of those in front of the middle of the arrow? How many of those
Right.
percentage of this
Yeah.
arrow length is the actual center of mass in front of the center of the arrow? So basically, if this length 10% of the arrow length, if the center of mass is farther, it might be 15% of the arrow length. If the center of mass is way up here somewhere, it might be 30%. That's the ultra high FOC stuff that Ashby talks about. The farther up the balance point is, the greater the FOC, and that percentage again is just a percentage of the total arrow length.
Hmm.
What percentage of the total arrow length is this thing in front of the middle of the arrow? Okay, so that's the FOC, and importantly, that center of mass is where gravity actually acts. This is something Newton showed, that you can show that that although gravity is acting along the whole arrow, because gravity is a force and it's a vector quantity, you can add up all of those and find the basic place that it acts at, and that turns out to be the center of mass of the arrow.
Right.
So you can think of gravity as acting straight down here.
Hmm.
And so what happens as the arrow is in flight is it encounters two forces. It encounters the force of gravity, and it also encounters drag. So as it's moving through air, it's obviously penetrating this fluid that we call our atmosphere, and that induces a force that the force in this case is always pointed in the opposite direction of the velocity. So drag, if the thing's moving this way, the drag's going to be pointed that way. If it's moving this way, the drag's going to be pointed that way. So the
Right.
drag is proportional to the velocity of the arrow. In fact, it's proportional to the speed of the arrow squared. That's fluid drag for things like that's the kind of thing you would see in a ballistics calculator. And that does show up in some of the videos that I've posted online. So that's what this thing has acting on it as it's moving through the air. You were asking about gravity. So most of the time, what we do is we ignore drag over short distances and through not very dense fluids like air. You can pretty much ignore the drag and just calculate what's going on with the gravity. And so where gravity really plays a role in archery, particularly from a hunting perspective, is in trajectory. So one of the curious and interesting things about the gravitational force is that it is independent of the mass of the object. What do I mean by that? The acceleration due to gravity is independent of the mass. So if I take this thing here and I drop it, okay, it accelerates at a certain amount towards the ground. If I took a pile of feathers and dropped them, then you would say, okay, those accelerate slower. They sort of do this, and it takes longer to reach the ground. That is entirely an artifact of the fact that there's air, and that drag is acting on the
Oh,
feathers
right.
with a much higher force to keep them from accelerating. If we sucked all the air out of this room, and you can look these experiments up on YouTube, there's bunches of them. But if you sucked all the air out of this room and you took this arrow and the pile of feathers, and you held them next to each other and dropped them, they would fall at the same time and hit the ground at the same time.
Uh-huh.
Um, that's a curious feature of gravity. It's an interesting one, and it's one of the things that in the history of this stuff you can go back and look and see how that feature really pushed Newton in the correct direction for describing a lot of the things that he described. But what does that mean for an archer? It means that if I use this arrow, which is 500 grains or whatever it is, and I use an arrow that's 800 grains, the two are going to accelerate towards the ground at exactly the same rate, 32.2 feet per second. Okay. So if I take my 500 grain arrow and my 800 grain arrow and I hold them next to each other and I let them go, they hit the ground at the same time. Okay.
Okay.
Now, if the arrow is actually moving,
Hmm.
that doesn't change anything. So the arrow is actually moving here, and it still takes the same amount of time for it to go from here to hitting the ground. So let's say that it takes 2/10 of a second to drop at whatever it is,
Yeah.
a meter and a half, whatever it is. So the two arrows are going to drop the same amount in the same amount of time. So in the same amount of time, they'll both hit the ground at the same time.
Right.
But my 500 grain arrow, if I am shooting it, if they're both being shot from the same bow,
Yep.
500 grain arrow is going to be moving this direction a lot faster. So although it takes them the same amount of time to hit the ground,
Oh, yeah.
this
Makes
one will
sense.
have gone a lot farther in
Uh-huh.
that amount of time than the heavier arrow.
Right. Yeah.
So what happens is that the heavier your arrow is, the more gravity plays a role in your trajectory, because over the same distance, this one will have fallen less, not because it's falling at a different rate, but because it spends less time falling. It gets there faster.
Right.
Right?
Yeah.
So with my heavier arrow, what does that mean? That means I'm going to have to either sight in, if I'm using a compound bow, I'm going to have to sight in at a where I'm actually aiming higher, so that as it's moving slower, it falls into the same place that this one would hit.
Hmm.
And if I'm shooting traditional, I have to use a gap method or instinctual or whatever. I'm going to be aiming one way or the other. I'm going to be aiming higher on my target because it takes longer for the heavy arrow to get there, and during that length of time, it falls a greater distance because of the fact that gravity has uniform acceleration independent of mass.
Right.
So that's really the only place that I see gravity playing a role in this. And so this is where you get to this idea of a trade-off. So you go back, you say, I've got this particular bow, and this particular bow produces a certain amount of kinetic energy, and that's how much energy I have. Then your next question is, okay, I want to take this mass, this arrow mass, and I can shoot a really heavy arrow. Okay, and that's going to give me a lot of momentum. If that's important to you, it's for reasons we could talk about later. It's not important to me, but I could shoot a heavy arrow. And if I shoot this really heavy arrow, I'm going to have a lot of momentum. Yay. The problem is now you've got this arching trajectory because it takes longer for the arrow to get there, more momentum, but slower. It takes longer for the arrow to get there, and over that time, it's going to result in it falling at a further distance, same
Right.
rate, further distance.
Question
And
for you. So we're
yeah,
shooting one arrow that's 500 grains, one arrow that's
sure.
800 grains. I'll grab an arrow too. So, um, for the people who are watching, so we have one that's 800, one that's 500. Now we hit an animal. Does the weight, like, it still carries momentum? Now the animal is the outside object that's stopping the arrow or slowing the arrow down.
Yep.
So the weight of the arrow, does that have any influence on how much that arrow is being slowed down?
All right. So I'm gonna be very technical because I think I hope that's what we want.
Yes.
So this is a common mistake that is made in, and it's just good to keep things straight in your mind. There's a difference between mass and weight. So mass is the essentially the amount of material in this arrow.
Mhm.
Weight is the gravitational acceleration of that mass, the gravitational force acting on this.
Down. Yeah.
So they're actually not the same thing. That's why you can take an arrow out in space and say it's weightless in space, but it still has the exact same mass. Okay, because the weight is actually a measure of how strong gravity is pulling on it, and the mass is
Oh,
a measure of essentially how much
yeah, yeah.
stuff is
Makes
in here.
sense. Yeah.
So that being said, everyone confuses the term mass and weight, and I will too. I will say weight occasionally when what I mean is actually mass. So I think the question you're asking is what does the mass do? So if I've got an arrow that has 500 grains of mass versus an arrow that has 800 grams of mass, what's the difference of those two things when it hits an animal? Okay, so the idea here is that the animal is that there's going to be a certain amount of force exerted on the animal by the arrow when it hits, and there will be a certain amount of force exerted on the arrow by the animal when it hits. Okay, these two things hit into each other. And this is where you referenced earlier Newton's third law. This is where Newton's third law comes in, and it says that if the arrow hits the animal and exerts a particular force on the animal, then by Newton's third law, the animal exerts exactly the same magnitude of force back on the arrow.
Oh,
So
okay.
the arrow will feel a certain amount of force, and the animal will feel a certain amount of force. Probably a little bit more specific example is if you were to fire this into a concrete block, right? So when this thing hits a concrete block, it's exerting a force on the concrete block, and the concrete block is exerting a force on the arrow. Okay.
Arrow break.
What's that?
And then the arrow breaks. That makes
And
sense.
then
Yeah.
the arrow breaks. Yeah, yeah.
Yeah.
And the reason is,
Exactly.
and this is again something I've ran across and struggled with people online about because um, there is a misconception, and I'm going to blame Ashby for this one because this was something that came up in his articles that I don't know if he's the first person that said this, but it certainly it has been perpetrated. perpetuated by people who have read the Ashby reports, and that is that somehow the momentum of your arrow tells you how much force the arrow has. So this is one of the arguments for high momentum archery. Oh, if you have a high momentum system, then that generates more force. And that's simply not true. This arrow has no force. The arrow does not have force. The
Yeah,
wall does
it
not
doesn't
have.
fly. Yeah, the arrow won't fly unless we do
Yeah.
something with it.
Well,
Right.
a force is a description of the interaction of two different things. So the arrow doesn't have force. The wall doesn't have force. So if I touch the arrow against the wall like this, now the arrow is exerting a force on the wall that wasn't there before. The arrow wasn't exerting this force forward. It's not like there's force coming out of the end of the arrow. The arrow's
Right.
not
Yeah.
doing anything. It's only when it touches.
Right.
Now it's called a contact force. There's contact between the wall and the arrow. And now if I push on this harder and harder, that force gets bigger and bigger. And if I push on it less and less, the force gets less and less and less until I pull it off the wall, in which
Right.
case the force goes to zero. So this force is a description of the interaction of the wall with the arrow, okay, and with me pushing on the end of it.
Right.
And there's nothing about this arrow that says it has a certain amount of force. So the force is going to be larger for hitting a piece of concrete than it is for hitting an animal. And this is why you can shoot the same arrow through 100 different animals, particularly if you don't hit any really heavy bone.
Hmm.
But you try to shoot your arrow through this concrete block, once, and that's going to be the end of it for the arrow, because the arrow is going to have a lot more forces exerted on it, and those forces are actually going to be too great for the internal structure of the arrow to stand up to. Once those forces get above a certain threshold, the arrow is just going to break,
Right.
right? So this idea that momentum somehow tells you how much force you have is incorrect. The amount of momentum, it does not limit the amount of force. And this was something specifically in the Ashby reports, was the description of that the momentum tells you the available arrow force, is what he says. The available arrow force is given by the momentum, and it's just not true.
Oh, yeah,
It's
because an
just
arrow doesn't have any force at
yeah,
all.
yeah.
Yeah.
The arrow doesn't have any force. Nothing has any force. Any individual object does not have force. Any individual object, the force would be two things interacting with each other. How
Gotcha.
strongly are they interacting with each other? The arrow is much more strongly interacting with this piece of concrete than it would be going through air. So the
Right.
force as it's going through air is way less than the force of
Going
it
through
of
the
it
block
hitting a piece
wall.
of concrete,
Yeah.
right? So the description depends on more than just the one body. To talk about forces, you have to talk about the arrow interacting with something. So it's either interacting with the wall, that's a contact force, or it's interacting with the planet, and that's a gravitational force.
Right.
But it doesn't have any forces. I can't measure the force in this arrow and say this arrow has 500 newtons of force. That's not how it works. Okay, so that's an important thing to know, because I've run across people rationalizing things like high momentum archery by saying that, well, that arrow is going to have more force, and so it has more force, and that's what allows it to penetrate the animal better.
Yeah,
And
you
that's
hear
simply
that all
not
the
true.
time. You hear it all
Yeah,
the time.
that's simply not true. That's not what momentum tells you. It doesn't tell you about the forces. The forces are functions of other things
Right.
than momentum. So
Yeah.
so that yeah. So you're sorry. I I'm a science person, and I get easily distracted and run on tangents. So
No, I
stop me
love
and
it.
slow down if
No,
you need me
no,
to go somewhere else. But
no.
we were talking about the animal penetrating, the arrow penetrating the animal, and the question of how different masses will play a role there. Is that what we want to do
Yeah.
next?
Yeah.
Okay, so this is one that's sort of interesting. There's lots of anecdotal evidence, right? There's lots of, if you sort of polled archers, hunters, not archers, but hunters, people that use archery for hunting, and sort of just got a consensus on all things being equal, if you have two arrows with the same kinetic energy, shot from the same bow, and you're not worried about trajectory, you're not asking about, am I going to hit the animal in the right place or not, assuming you hit the animal in the same place, two arrows, same amount of energy, one's
Yep.
heavier than the other. Most archers, I think, would say that the heavier arrow is going to outpenetrate the lighter arrow. The more massive arrow is going
Yep.
to outpenetrate the less massive arrow. That would have been certainly classical. Going back 50 years, if you go back and look at Fred Bear, or you go back and look at a lot of the archers from there, most of the time they would have recommended a heavier arrow to get better penetration, a more massive arrow to get better penetration. So the question is that true or not? Is that a correct statement or not? So to do that, you really have to know what mass actually is. So mass comes from Newton's second law, and Newton's second law says that the force applied to a body will change its acceleration. So its acceleration will not change, will cause an acceleration. So arrow's moving, it's got this motion, it's got a particular velocity going like this. Forces act on the arrow and cause the arrow's velocity to change. It could either change by slowing it down, speeding it up, or it could also change by just changing its direction. That is also an acceleration. So it may not speed up or slow down, but if it's changing its direction, that also requires a force. Okay. Now, the question is, if I have two bodies that have the same force acting on them, like let's say a spring is pulling on them. One's a block that has a mass of 100 kilograms, and the other's a block that has a mass of 500 kilograms. You take the same spring, you attach it to this first one, you attach it to the second one, and you measure how fast the blocks start moving. And everyone intuitively understands that the more massive block with the same force applied to it is going to accelerate slower, right? You take a big, thick, heavy spring, you stretch it out a certain amount, and you put a golf ball on the end of it, and you attach it, and then you let the whole thing go, and you go, right? And then take the exact same spring, and you stretch it out to the exact same length, and you attach, I don't know, a semi-truck to it, and let it go. Well, the spring might start pulling, but you know that it's not going to accelerate. The velocity of that truck's not going to change nearly as rapidly as the velocity of the less massive thing, right?
Right.
So what mass actually measures is, it's called inertia. Mass measures for a given particular force, how much does a body resist a change in its motion? So a big, massive object, you put a force on it, it will change its motion. It will just do so at a lesser rate than if I take the exact same force and apply it to a smaller, less massive object. So if I have an arrow penetrating an animal, and I look at two different ones, my arrow 500 grains and your arrow 800 grains, all things being equal, if the forces were exactly the same, if the forces between the two arrows were exactly the same, then the more massive arrow would definitely penetrate further. And that's because the more mass means less
Yeah.
acceleration, a smaller change in velocity. It takes longer for the velocity of the arrow to change, and so the arrow is going to go further in that certain
Right.
amount of time.
Hmm.
So without question, if you have two arrows with everything the same forces, same initial velocity at impact, and one's more massive and the other is less massive, then the more massive one will penetrate better. That's not questionable.
Gotcha.
The problem is that you don't have everything else the same when you have two arrows, right? Because if
True.
I take my 500 grain arrow and I'm standing 20 yards away from my target,
Yeah.
and I shoot that 500 grain arrow with my bow, and then I take my 800 grain arrow and I shoot my 800 grain arrow with my bow. When they hit the target, they are not going to hit with the same force,
Right. Same
because
speed.
as we said, the force is not a property of the arrow. The force is a property of the interaction between the arrow and the object. And an arrow going, well, let's see, if you're shooting your 500 grain arrow, then it's going to be moving some number of feet per second faster at
Hmm.
impact than your 800 grain arrow is. So your 500 grain arrow is actually going to experience greater forces. The forces are going to be proportional to how fast this thing is going. it will experience greater forces, but it will also be moving at more feet per second into the animal.
Right.
So it has the disadvantage of it will experience larger forces as it's passing through the animal,
Uh-huh.
and the advantage of it doesn't have to experience those forces for as long because it's going through it much faster.
Right.
So it becomes a very complicated question. And this, I think, is where a lot of the uh, high mass versus low mass arrow kind of argument. Do we want high momentum, which really, again, most of the time when people say high momentum, what they really mean is heavy arrows,
Yeah.
versus high speed, again, lower mass arrows. This is where the confusion comes from. Because if they really did hit with exactly the same speed and have the exact same forces exerted on them, the heavier arrow would absolutely go through it further every single time.
Right.
But usually you're shooting from the same bow. And since
Yes.
you're shooting from the same bow, the heavier arrow does have the advantage of having lower impact forces, but it's moving slower. So it takes it more time to go through the animal. And those two factors have to be balanced.
Right.
And so if it's moving slower, it doesn't require as much force to decelerate it to a stop.
Yes.
Um,
Gotcha.
uh, as opposed to the higher arrow, which is exerting more, is feeling more forces acting on it, but it's moving faster and it requires a lot more forces to bring it to a rest before it's completely done.
Yeah. And I
So
guess the faster, if you want to make that heavier arrow go faster, you have to add more force, which means you have to have more poundage on your bow.
yeah. So if you want the for the same mass arrow, if you want it to go faster, if you want these two arrows to hit, my 500 grain arrow, my 500 grain arrow hitting the animal, and my 800 grain arrow hitting the animal, and I want them both to hit at the same speed, at this 180 feet per second, 285, whatever it is that I want the arrow to actually hit. If you want that, the only way to do that is to, as you're increasing arrow weight, to proportionally increase draw pound, the energy stored in your bow. So you
Hmm.
have to have a quote faster bow in order to do that. So and everyone knows this, right? I have issues with penetration. Well, what should I do? Well, one thing you could do is you could shoot a heavier arrow with a heavier bow, and
Hmm.
everyone would agree. Okay, if you do those two things, you'll definitely get better penetration, right? That's no one I think would make the argument that if I use a higher poundage bow, and I use a heavier arrow, that I'm somehow going to end up with a system that penetrates less. That's it's pretty obvious that if you do both of those proportionally, that you'll end up with, first of all, an arrow moving the same speed. That's what you did it for, so you're not losing any velocity. But it's heavier and it's got more energy. It's clearly going to penetrate better.
Hmm.
The question is, most people don't do that. Most people have the same bow and they're looking for the optimal mass so that they end up with better penetration.
Yeah, I know a lot of people. Yeah, FOC is just such a huge topic, and they figure the heavier the arrow is in the front of the arrow, the flatter or the longer it's going to fly flatter, and the better the impact you're going to have.
Yeah, so there's lots of stuff that goes on with FOC, and we should probably talk about that. I would like to get through some of uh, the more sort of the more sort of um, elementary aspects
Yeah,
before, because
yeah,
FOC has a lot of stuff that goes into it.
yep.
But yeah, that's the idea. What you'll see a lot of people get recommended is, oh, just go to a heavier arrow and you'll get better penetration. Or then sometimes you'll see, well, you don't have to go to a heavier arrow, just build your arrow with a higher FOC, and you'll get better penetration. Um, I think the second of those is probably a misguided, but certainly experience would tell me that with the same bow, in most cases, increasing the mass of the arrow is going to actually lead to better penetration in animals. But I can't say that from a scientific standpoint. I can only
Hmm.
say that from an experiential standpoint. In that I think there's a lot of of evidence of people saying, well, I was having trouble with penetration and I went to a heavier arrow and I had better penetration after that.
Yeah, yeah,
Uh, the reason I can't say it scientifically is because again, you have to be very careful about the interplay between the fact that you're increasing the mass of the arrow and from the same bow, that means it's going to be going slower, and that means the impact forces are going to be different. And once you have different impact forces, it becomes a complicated mess. So I think
definitely.
I actually had a really long video on this that I would encourage people that are interested in have a little bit of at least willingness to dabble in calculus, to look at this, because I think it helps clarify the misconception about using things like a foam target, to measure penetration and compare that to how an animal would behave. Because again, what happens is it all depends on your substrate. As the arrow hits the substrate, there's going to be certain forces exerted on the arrow, but the forces that get exerted on the arrow as it's going through a piece of foam or as it's going through a piece of oh
Like
shoot,
that gel, that
yeah,
arrow
yeah,
shooting
ballistic
to that
gel.
gel. Yeah.
As it's going through a piece of ballistic shell, the forces and the way the forces that are acting on the arrow and that material is or at least could be very very different than the forces acting on as it's going through, say, soft
Yes.
flesh.
Well, and
Um,
it changes too as you go through a deer. I mean, on some animals, like a buffalo, the hide is a lot thicker. Then once you get through the hide, flesh, heart, lung, all that stuff is a lot easier than getting through that hide to
Yeah, you've
begin
got
with.
hide, you've got bone, you've got connective tissue, you've got musculature, you've got your organ tissues. All that stuff is going to exert different forces, depending on how it reacts. For instance, a lot of soft tissues are actually sort of under tension. So, like you've probably noticed this: if you cut yourself a certain way, that thing wants to open up as opposed to squished together.
Right.
And so if you've got a broadhead that's cutting something and it's going to want to tend to open a little bit, you're going to get a very very different force acting on the arrow as it's going through that than as it's going through a piece of foam, and a piece of foam is trying to squeeze shut. A piece of foam
Yes,
is literally trying to squeeze shut,
totally.
and that's how foam works. I if I can find it, I'll send you a link and maybe you can post it
Yeah.
on podcast. There's a video I found um, several years ago online on YouTube that just blew my mind. It makes perfect sense in retrospect, but when I was first watched it, I was like, what is happening? And this archer was demonstrating the way that foam works, and he had just a standard arrow with a fill tip on it, and then he had an arrow with like a blunt, like you would use for a small game head
Yeah.
or something like
Yeah.
and the blunt was one of these hexagonal six-sided sort of
Hmm.
cut things like this. And he had a piece of foam. It was not a archery target. It was essentially like a yoga mat material, like thin.
Yeah.
It was only about this thick, right?
Right.
Um, and so he was like, okay, I'm going to shoot these two arrows, and I was like, okay, I'm going to anticipate what's going to happen with these two arrows. And I thought to myself, okay, I've got this arrow with the filled tip. It's got a point on the end of it. It's going to hit that foam. It's going to spread the foam apart. It's not going to like dig into the foam. It's not going to catch it. It's going to spread the foam apart, and this thing will pass through the foam. It's the foam's only this thick. It's not enough foam to catch the arrow, right? And so it's just going to go through. And then I thought with that other arrow, it's just going to hit, and because you're hitting something like this,
Yeah.
it's not pushing through. It's going to hit like this, and it's just going to catch it and bounce it off.
Right.
The exact opposite happens. So this hits the foam, it goes in about this far, and then it sticks like
Right.
this.
Yeah.
And then he fires the blunt and just straight through, no stopping.
Oh.
And I thought, what happened there? And he takes the foam and he shows it afterwards. And what's happened is after you remove the arrow with the fill tip on it, you can see a little sort of hole, but the foam was still there, and it was contracting. So as
Oh, yeah,
the
yeah.
as the as the arrow went through, it spread the foam apart, and then
And
the
then it
foam is
tightened back up
pinching
on the
back,
shaft.
trying, and it's exerting enough force as it's pinching down to catch
Oh,
that arrow.
yeah.
And then he showed the blunt, and that blunt hit and punched the hole out of the
Blew it
foam.
open,
The
which
foam
is
wasn't
big.
there anymore,
Yeah,
and
the
there's
hole
nothing
is
there actually.
essentially bigger
Yeah, he just made a
diameter than the
hole.
shaft. Yeah.
Yeah, he just made a hole, and then the
Ah,
shaft just followed through the hole. There
interesting.
was nothing,
Yeah.
punching there. So the point is, the foam is designed for for things like field tips. The way it works is that big foam block you have is that thing as it's going through is squeezing the arrow. It's capturing the
Right.
arrow this way. It would be no different than the trick shot guys who, as the arrow is coming towards them, they snatch it out of the air, right? And how they're doing that, they're grabbing it and squeezing it from either side. They're putting pressure on it, and that's
Right.
enough to catch the arrow, right?
So yeah, so I guess when you
Whereas,
see guys doing these YouTube videos of like broadhead testing and that, it's not really a good representation of what it's going to do in an animal because it's going to be acting two different ways. Like you said, an
yeah, yeah,
animal's hit it, it's going to be under tension, and once you cut tension, it opens up.
yeah.
It's going to allow less friction for that arrow to
Well,
move.
the animal is also, you've got blood, so it's also lubricated, right?
Right.
You've
Yeah.
got lubrication. You've got the fact that some of the material might be under tension and tends to open up instead as opposed to squeeze down.
Yeah.
And this also, of course, it explains why probably the most important factor in actual animal penetration is animal reaction, right? So if you happen to fire and the animal happens to be turning one way or the other so that they're
Yeah.
pinching, when that thing hits, if they pinch on it, it's just going to grab it the
Yes.
same way the foam does if the animal happens to be reacting in a funny way. So you can have the best setup, quote, best setup in the world for penetration. And if the animal does something funny, and moves or jumps the string in a certain particular way, then you can get very little penetration just from that thing basically catching the arrow.
Yeah, and you
Um,
see it a lot in whitetail hunting where that you shoot, it hears the string and it's already started its momentum, it's already started to move, and then the arrow hits it and you don't get a pass through. Whereas like you shoot the same animal and it's standing in place and it doesn't move and you get a complete pass through.
yeah,
And
yeah,
like
yeah, yeah.
you'll see the whitetail running off and he's got half an arrow sticking in him.
Yeah, yeah, and that's that.
Makes sense.
So yeah, that unfortunately, animal. Was it Ranch Fairy who says the animal has participates in this activity? Right, the
Yeah.
animal has does some things too, and this is why I think the big deal of having something a quiet setup is so important because the more
Mhm.
reactive the animal is, the more likely you're going to get some of these pinching forces that
Yeah.
really devastate arrow flight. Like
But I mean,
you can take an ant. Go ahead.
one thing to ask you though is like to quiet the string down, we have to add like vibration dampeners and stuff, and that essentially slows it down. So we are going to sacrifice a little bit of force, momentum, losing speed.
You're gonna sacrifice a little bit of energy.
Yeah.
The other thing you can do is go to heavier arrows. And again, because heavier arrows tend to be a little bit more efficient, that tends to make things a little bit quieter. Slower arrows actually will be a little bit quieter because they're moving through the air at lower speed.
Yeah.
And because they're moving through the air at lower speed, they're producing less drag. And
Right.
the sound of an arrow moving through the air is basically a property of the drag. So it's setting up pressure waves, and those pressure waves are what you hear as the arrow moves through. The faster the arrow is moving, the louder it's going to sound. So a heavier arrow can actually be a little bit quieter. The problem is the heavier arrow takes longer to get there. So even if it's quieter, that might not actually help you when it
Right.
comes when it comes to sound.
Yeah.
So yeah, there's just a lot of different things that go on with what works best. What I can say is that if it were me suggesting to someone and they were to tell me I'm having penetration issues with my setup, the first thing that I would do is encourage them to go up, not drastically, but I wouldn't say, oh, go shoot a 900 grain arrow. All right, that's a bit of a silly thing. But
Hmm.
if they say, well, I've been shooting this 425 grain arrow and I feel like I'm getting a little bit of problems with penetration consistently, not just one time. That's the other thing to say. If someone comes in and says, I've been shooting this setup for years and it's worked great for me, I always get pass throughs, But this particular season, I shot the buck of a lifetime, and I only got 4 inches of penetration, and I need to do something different. I would say let's make sure that that's a consistent problem first,
Right.
because we said depending on how the animal reacts, you could have a perfectly fine system that works just great for you, and you're gonna have times where something funny happens with the way the animal reacts, with the specific way that the hit occurs on the animal, that even the best systems in the world, it's you're just not going to get great penetration. That's something we have to live with as archers, right? We're
Yeah.
not shooting, this is not rifles. We're dealing with several thousand foot-pounds of kinetic energy. We're working with less than 100.
Yeah.
And so occasionally you're going to have something happen where it's just going to be a problem. But if you're consistently not getting the penetration that you want, well, the first place I go is, what kind of broadhead are you shooting?
Yeah.
That's not really sort of the basics of physics, but that's the first thing that I would ask. And then the suggestion would be, well, maybe bump up your arrow weight, your mass, not drastically, but 50 grains, 75 grains, 100 grains, and see if things work out a little bit better.
Yeah.
That would be the first place that I would go when it comes to, and most people don't want to change bows. I don't think it's fair to tell someone who's struggling with pulling 65 pounds that they need to be shooting 80 pounds. That's not helpful. Will it help increase their penetration? Yeah, of course it will. It's a much heavier bow, but then it might make archery miserable and cause injury and all kinds of other things. So the place I start with would be, let's bump up the arrow mass a little bit and just see what happens.
Yeah,
And if that
definitely.
doesn't work, then we'll look at some other things.
Yeah, and shot placement is huge too. I know for
Yeah,
like I hit a buffalo once and um it only air only went in maybe 4 inches and stopped. And because the buffalo they have this big cartilage on the top of their shoulder and I was just high. And then the next one I got a pass through because
yeah,
my shot placement was a lot better. I was a little nervous on the first one and kind of moved and I kind of rushed it. But
yeah,
second one,
yeah.
better shot. But
Yeah, yeah, there's so much that goes into archery. That's why I love the physics aspect of it, but uh when it comes to, so the way I think about it is, I use physics to try to develop what I consider to be the optimal system for me, but then I'm going to have to recognize that optimal system is really going to be within a range of results.
yes.
That just because I have an optimal system does not guarantee that every time I look at an animal I'm getting a pass through. Right?
Yeah.
That's just not the way archery is going to work.
No,
And
exactly.
so I want to optimize the system so that I have um, the, what I consider to be a decent enough mass for my arrow to get good penetration, but I also have enough speed that I'm not, moonshotting in arrows and trying to get, at that point you have to do, well, I'm a traditional archer, so I wouldn't shoot an animal more than 20 yards away anyway. But if with a compound or whatever, you have to be careful about sort of moonshotting things in there. It needs to get to the animal fast enough that the animal doesn't have a huge amount of time to jump the string, because they're going to hear it. They're going to hear it, and they're going to have some reaction time. There's just a lot of things in play there, and you have to recognize that there is no foolproof guarantee in archery. It just doesn't exist. And if you have one bad result, that is not an that does not it does not necessitate that you go in and change everything about your system.
No, exactly. Because there's a lot of outside variables, and what we're talking
Yeah,
about is like the physics of archery of like how everything works. But every instance is different. You have more, wind can be different. There's just so many outside variables that come into play when you're shooting archery or you're hunting. So especially hunting. I
yeah,
mean, hunting everything amplifies, right? So
yeah, yeah. I think that's yeah, that's kind of what I wanted to get at, because I do think that there is physics that's important, but I also want people to recognize that being good shot, taking ethical shots, and making sure that your shot placement is good, understanding animal behavior and anatomy. All of these things are going
Huge.
to play in much more to being a successful hunter than if you understand kinetic energy versus momentum.
Yep.
That's it's not that those things aren't important. They're just what interests me, and
Yep.
I enjoy thinking about them. But when it comes to actually being successful as a hunter, there are things you can learn from physics, but there are also a lot of other things that are as, and I would argue, significantly more important when it comes to success than if your arrow is 500 grains versus 545 grains. Right?
Right.
That's just not that's small potatoes compared to the rest of it.
Right. Exactly. So, was there any more of the like the introductory stuff, the physical stuff that you wanted to cover?
I don't think so. I think yeah, the only things that I would like to sort of jump into now are more specific examples of things like FOC
Yes. Okay.
and maybe um the heavy bone threshold. Those are things that have popped up as questions for me over time,
Yeah.
and those were
Okay.
kind of fun to talk about.
Yeah. So why don't you hit those? What's on your mind there with those? Because like
So,
when we get into the physics stuff, I don't know the right questions to ask because I don't know anything about it. So
well, the FOC one is one that's interested me because uh, so I've kind of ragged a little bit on Ashby, and if people think that I'm anti Ashby, then that they're wrong. I'm not. The I have sort of a love hate relationship with the Ashby reports. Um, I am I don't question his data. So he's collected a lot of data in his
tons.
and the Ashby Foundation has collected a lot of data over the years, and I think that data is good data. I don't think that there's any sort of systematic errors in the data that is so consequential that one could just look at his data and just throw it out and say that this data doesn't matter. What I do question with those reports is the interpretation of the data and what the data is actually telling you. And I just think that many of those interpretations are flat out wrong. So the ones that tend to come up the most are FOC. FOC's king. That's the one that everyone wants to argue about. And then follow that with probably mechanical advantage of a broadhead. That one is one that comes up a lot. Ashby adherents would say you got to use fixed blade, two blade broadhead that's this long and this narrow, and that's the only thing that will actually work for animal penetration. And then there's heavy bone threshold that your arrow has to be over 650 grains, and if it's not over 650 grains, it's going to get stuck in a in a in a in a twig on the way to the animal, that kind of stuff. So the FOC one is the biggest one, and that's kind of we've already touched on it, so it would probably be a good idea to start there.
Yeah.
But FOC, again, just to if I'm sure most of your listeners, all of them, probably know this already. But FOC basically is a measure of how far the center of mass is in front of the center of the arrow. And so the question is, why is that important? All right, so there's some places where we absolutely know that that's important. The place that we absolutely know this is important is in stability of flight. So the stability of aeroflight. So basically, what's happening there, and I'm not an aerodynamicist. I'm not an engineer in aerodynamics. So my understanding of this is about as basic as you can imagine. But essentially, what happens is that we have this. All right, let me take a step back. There is a theorem in physics that shows that the only thing that you really need to know how a body is moving is you need to know its center of mass and you need to know the net forces acting on the body. So what does that mean? That means that as far as this arrow is concerned, if this is the center of mass here, this is the balance point, this is the center of mass here, If I know all of the external forces acting on this arrow, in the case of archery, it would be gravity and it would be the drag forces acting on the arrow. If I know all of those, I can completely forget about the rest of the arrow. Arrow's gone, and think about just a point, a little BB that has the same mass as the arrow at the center of mass, and I can calculate the entire trajectory of the arrow without thinking about any of the rest of the arrow. I just think about what's happening at the center of mass and what forces are acting on the system. This is why you can calculate things like the trajectory of the moon and the earth around the sun.
Okay.
So the moon and the earth is a system, and the moon is moving around the earth. The earth is actually wobbling a little bit around the center of mass as the moon moves around. So they're actually doing sort of this little dance. And if you think about trying to calculate how that dance is occurring as it goes in orbit around the sun on a yearly basis, you could think to yourself, well, that would be really, really difficult to calculate. If you had to calculate what's going on inside of the system, what's happening inside of the system in order to know how the system is moving, well, you could take it that further. The Earth has tornadoes, and it's got volcanoes, and it's got hurricanes, and it's got jet streams. It's got all kinds of wacky stuff going on. Do you need to know all that stuff in order to know how the Earth is going to go around the sun? And the answer is no, because what you can do is you just calculate the center of mass of that system, and you ask what external forces are acting on that system. And that's the moon, the earth, all the stuff going on inside the earth, all the people running around doing crazy things on the surface of the earth. Doesn't matter. You find the center of mass of that. And then you say, what is the net force acting on that whole system? Well, in space, there's no drag. There's nothing that it's going through. So there's no drag. So the only force acting on that system is the force of gravity from the sun. So you can replace the entire Earth Moon system with a point that has the exact same mass as the Earth, and you can calculate how would that point go around the sun.
Okay.
And then you go back to your Earth Moon system, and you will see that it follows exactly that same trajectory.
Right.
So this is a way of really simplifying how you do calculations, because you don't have to know what's going on in the back of the arrow and the front of the arrow. You don't have to know any of that stuff. You just need to know the center of mass and the external forces to calculate the trajectory. Okay.
Right.
So what I've heard people say is, well, okay, here's the center of mass. Here's the center of the arrow. If I move my FOC up, here's the center of the mass. Or if I move my FOC back, here's the center of the mass. But why should that matter? Because by this theorem, all I need to know is that there is a center of mass, and I just calculate things from there. And it doesn't matter. It shouldn't matter that it's closer to the front of the arrow, and it shouldn't matter that it's farther back in the arrow. That's going to have no effect at all, because all I need to know is where the center of mass is, and I can do the calculations. And it doesn't matter if it's at the back of the arrow or the front of the arrow, the arrow is going to move the same way. Okay. That's sort of the same thing as saying, okay, I've got the sun and the moon here, and I've calculated the center of mass. Now I just figure out what the center of mass is doing, and I don't have to worry about the rest of it. And whether or not the center of mass is, closer to the moon, or whether or not the center of mass is closer to the earth, that doesn't matter. It's just going to follow the trajectory that we calculate. So whether or not the center of mass is way up here or it's way back here, that doesn't matter. It's going to do what it's doing, and the arrow just goes with it. Okay. Right. That was my initial, like, when someone said FOC is going to make an important difference in penetration in an animal, that was the initial thing, my initial reaction. And I've actually seen some engineers, I think Bill at Iron Will, he's talked about this before, sort of making the same argument. There's no reason why where the center of mass is should affect things. You just know that you've got the center of mass. You hit the animal, you've got some external forces acting on the center of mass, and the center of mass is going to punch through. And it doesn't matter if it's at the front or the back, the arrow should do the exact same thing, independent of where the center of mass is. It's just going to do whatever it does. And that turns out to not be quite correct. And the reason is because where the center of mass is going to make a big difference on how the arrow flexes in it's doing things. Okay.
Right.
So for instance, if you're firing the arrow, you fire an arrow that has a very high forward of center. So it's a very high forward of center. What do we know we have to do? What do we have to do to the shaft in order to get that to tune? So to get a really high forward center arrow to tune, you are typically going to have to increase the spine of the arrow. You're going to
Yeah.
typically have to increase the stiffness of the arrow shaft, because if you've got a lot of weight out here when you go to fire it from the bow, what happens to this arrow is it's actually going to flex more. It's
Yeah.
actually going to flex more. So where the center of mass is will change how the arrow is flexing. Okay, it
Okay.
can. I should say will. I say it should say it can. It can change the way that the arrow is flexing. And what happens is as the way the arrow is flexing changes, that can in turn change the external forces. So if I imagine an arrow going through material and the arrow is basically not flexing, and I imagine what kinds of forces is this material placing on the arrow. Well, as the arrow is going through, if the arrow is essentially not flexing, then that will accrue very different forces than if as it's going through, it's doing this number as it's going
Right. Yeah.
through. That's going to cause
It's
different kinds
flexing
of
lots. Yeah.
forces to occur. So even though the center of mass doesn't care about where it is, as long as you know the external forces themselves will actually change depending on what's going on with sort of the structure of the arrow and where the center of mass is.
Right.
So this is what happens sort of in arrow flight. In arrow flight, there are two kinds of forces that occur that work on the arrow. There's the drag force, and then there's the gravity. Gravity acts on the center of mass, and the drag force, because it's a vector, you can calculate basically where the vector is. It's called the center of pressure. It's effectively because you have your veins in the back here. Your veins are actually producing a lot more drag than the rest of the arrow. That's why we use them. And so you actually end up with a force acting back here. And the further that is behind the center of mass, the more it tends to keep the arrow straight in flight.
Okay.
So if you've got your center of pressure, let's say the center of pressure is somewhere here, and that's where the center of pressure is, and
Yeah.
your center of mass is here, the center of pressure is sort of pushing back this way. It's causing it to slow down. And that keeps this thing stable. It keeps the projectile stable. If you take and reverse that and put the center of mass back here somewhere, and we're somehow to have the center of pressure this way, in other words, if you tried to do something stupid and fire your arrow out of the bow like this,
Backwards. Yeah. So
yeah,
you're
backwards.
switching everything around. Yeah.
What will actually happen is this thing will try to flip over and turn around. Okay,
Oh, really?
it will have a very unstable flight, because stable flight happens when the center of pressure is behind the center of mass.
Oh,
Okay?
okay.
This is why you don't see planes flying backwards, because
Right.
your tail back there is ensuring that the center of pressure is behind the center of mass of the airplane.
Okay. So
So
by increasing the point weight, we're moving the center of mass forward and then creating a bigger distance between the center of pressure and the center of mass, right?
and that's that it's producing a lever arm, which basically means that it's exactly like a lever. That if the center of pressure here and the center of mass is here, the distance between the two of them, you have to have a larger pressure here in order to get the same amount of stabilization.
Yeah,
The
leverage.
farther it
Yeah.
is, you need less pressure and less leverage. This is
Yes.
why you see some guys go to extreme FOC arrows, strip off their veins, and still be able to shoot the arrow.
Right.
Well, bear shaft the arrow and still have really good flight. Even with a broadhead. I've seen a guy who shoots a 38% FOC arrow with a two blade fixed blade broadhead, and bare shafted, and still get good arrow flight, which
Oh,
is
okay.
kind
Well,
of
that would
crazy.
explain a lot of the stuff that we see Ranch Fairy doing. Right.
Yeah,
Gotcha.
yeah. So the there is no doubt. Now, what I would argue is that once you have stable arrow flight, you have stable arrow flight. So if you've tuned your bow and you've got a good a bow an arrow that's flying really really well with 10% FOC, just arbitrarily shooting your FOC up to 20%, well, you're not going to get better flight because you've already got stable flight.
Yes.
You see what I'm
Yeah.
saying?
Yeah.
So
Yeah.
I think that there is this argument that some people say is, oh, if you just increase your FOC, you'll get better arrow flight. But you go and you see the Tim Gillinghams, and you see the guys that are professional competitors. They're not shooting these
No.
super FOC arrows. They don't need to because they've already got really good arrow flight.
Yes. Yeah.
So at some point that becomes, in my opinion, a little bit of a false thing to say that FOC is always going to improve your arrow flight. No, once you've got stable arrow flight, you've got stable arrow flight, and you're not going to get infinitely more stable arrow flight by adding 50 grains to your tip.
Yeah.
In fact, you could very easily end up with worse arrow flight
Definitely.
because you mess up the tune. You mess up the
Oh,
tune of the air
yeah.
to
And the
your
bow.
bow.
I mean, everyone, a lot of people have practiced with that, myself included. And, I don't run a super heavy arrow and I'm not a big FOC guy. And my arrows, they fly pretty damn straight. And if
Yeah.
I change any of the point weight, they go to garbage.
Yeah, I mean you can do it. You can go to a heavier FOC. You have to go to a stiffer arrow, or you have to cut the arrow down, one or the other.
Yeah.
You can play around with it, and you can get a good tune. I'm not saying that that's
Oh,
impossible,
yeah, definitely.
but I am saying that when you've got good arrow flight, you've got good arrow flight.
Yeah.
So if you're comfortable with your arrow and your arrow flight out to 40 yards or 60 yards or whatever you're hunting at, then to say, well, I should increase FOC because it's going to give me better arrow flight is a mistake. That's not a reason to
Mhm.
increase FOC in my opinion. Once you've accomplished good arrow flight, I think that that argument for an extremely high FOC goes out the window. You don't need it to be some giant, 20, 25, 30% FOC to have good arrow flight. That's just not true. We know competition archers generally just don't use FOC nearly that high, right?
No.
So and certainly Olympic archers and things like that would certainly use 30% FOC arrows if it gave them a competitive advantage. They've tried it. It doesn't. And so this argument that you should just bump FOC up until you can't handle it anymore because it's just going to give you better and better arrow flight is just not true.
Yeah.
So I guess the idea is you have to have a minimum FOC, and that's going to depend on the arrow and your vanes and whether or not you're using a broadhead or a field point or whatever. There's certainly a minimum FOC that you're going to have to get good arrow flight, but that's not going to be some number of 20+%, 18%. A lot of competition archers are shooting things like 5% FOC, 8% FOC, 12, whatever it happens to be. Most of the time, they don't even care about FOC. They just tune their arrows. And then once
Yeah.
they get good flight in the arrows, you want to check the FOC afterwards. Okay, go check it afterwards.
Yeah. Well,
But tuning your arrows is way more important than saying, I'm going to start with a 20% FOC arrow, and that's going to give me good arrow flight. That's not the way to go about things. Tune your
no,
arrows, tune
no,
your system.
exactly. Because they're not worried about penetration at all. As long as it's sticking in the paper or the target so they can see where it
Yeah.
hit, that's good enough. And I mean,
Yep.
anything that they're doing is like it's the best of the best in terms of archery, right? They're professionals
Yep.
for a reason. So,
Yep. So then you hit the second point of FOC, which is what I'm a little more interested in than arrow flight, is what happens at impact. What happens with an animal? And here's where I say that the Ashby reports, I'm happy with the data, and but not happy with the interpretation. One of the things that I dug through all the Ashby reports, and it's been several years since I sat down and read them all like a fine tooth comb. And there may have been things that have come out since then. But one of the things that's sort of buried in there is that in his studies, when he was shooting Cape Buffalo with, first of all, he was using very low poundage bows, but when he was shooting Cape Buffalo with these low poundage bows, um, he was testing FOC. Um, he presents no data and makes no claim that the FOC of an arrow makes any difference on hits in purely soft tissue. So basically, what he said is, if I were shooting these, and he was shooting the rib cages of these Cape Buffalo, right?
yep.
And if the arrow happened to miss any heavy bone, any tissue, that all the arrows just went through, and that there was no penetration issue. So basically, the idea is that I think that there have been a lot of people that have taken the Ashby reports, and he didn't specifically say this in his reports, but he has implied it in things like podcasts and other things that I've listened to over the years, that FOC will always increase penetration. That increasing FOC will always increase penetration. And the data simply does not show that. That's just not a question the data that the data shows, because there is no data presented for soft tissue hits, because he got full penetration on soft tissue hits regardless of FOC.
Right.
So that's not surprising. If you don't, most animal tissue, we're talking about dead animals now, right? They had killed the Cape buffalo. It's not moving. You don't. They did all these tests within, I think, 20 minutes of the animal
Oh
being
yeah, yeah.
seized. So what they would do is they would go out. They were coaling, and they would go out. They would have a dead buffalo. He would set up 20 yards. He would take his bow. He would shoot it like 10 times, 5 times, whatever it was, into basically the same spot on the Cape Buffalo, and then go in and measure the results. That's what he did, and he did this on many different animals.
Yeah.
Um, and basically he shows no report for it, no data for if this did not penetrate a bone, then there's no data to show, because if it didn't penetrate a bone, it just went through. Basically, with any arrow, with any broadhead, with any weight, at least within the parameters of what he was testing, everything just went through, because soft tissue does not, especially when it's not moving and not able to pinch. Soft tissue just doesn't catch these guys, right?
Right.
When they're going through. That's why arrows are good killers, because soft tissue doesn't do a good job of stopping arrows, right? It was only the bone that he was hitting, and in hits through these big, thick Cape buffalo ribs, when the arrow would hit the rib and go through, he was able to demonstrate that high FOC arrows had a better penetration after breaching the bone than low FOC arrows. So that data, I believe that data entirely, that high FOC arrows, when going through something really heavy where you have very large forces at work, very large impact forces at work, that high FOC arrows can, in principle, increase your penetration in those instances.
So does that go back to Newton's third law for like the amount of weight you put into
Yes.
something, it's coming
Yeah.
back? Yeah.
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 Because what happens is, if you hit soft tissue, the force that the arrow is exerting on the soft tissue, and by Newton's third law, the force that the soft tissue is exerting back on the arrow
Right. Yeah.
is small compared to if you hit something hard like this piece of concrete. Now that's
Exactly. Yeah.
it's even more hard than buffalo rib, but the buffalo rib being heavier and harder, when this thing hits, you're going to get a much larger impact force on the arrow and a much larger impact force on the bone. Okay, and the idea is you need that impact force to be large enough to actually break the bone, so that the arrow can actually continue to go through. Right.
Right.
So that's the idea. So the idea is, what are we actually seeing there from a physics perspective? From a physics perspective, this thing is hitting something hard, and it has a significant amount of force exerted on the arrow from this end when it's hitting that bone. Okay. So the question is there a physics reason why FOC would do better for that than why FOC shouldn't matter? So you've got two arguments. The first argument would be like, FOC just doesn't matter. Doesn't matter. The Ashby data is just wrong. Ashby's data is just wrong. And then the second argument is that FOC is just sort of this somehow magic thing that makes the arrow work better when it goes through these bones. And so what's the right answer? How do you figure that out? It took me a long time to figure this out, because I was looking at the arrow, and I was thinking about the arrow, and I was thinking about where the FOC is, the center of mass, versus where the center of the arrow is. And I was trying to gauge and see if there was something about the fact that those two, that the center of mass and the center of the arrow, if they're farther apart from each other, then maybe that the actual stiffness here, the longer you go, the less stiff the arrow is. The shorter is, the more stiff it is in that region. So
Right.
maybe having some longer distance between the front of center and the center of mass, maybe that causes the arrow to flex in some weird way. And it took me a little while to figure it out, but I think I do. I think, and I have a video specifically about this. To me, it's not really where the FOC is. It's not really where the center of mass is. That's sort of a red herring. It's not like, okay, this is the spot or this is the spot or this is the spot. That's not what matters. What matters is how much mass is in the head and in the insert, which is very stiff, and how much mass is in the rest of the arrow, which is not nearly as stiff as the broadhead and the insert behind the broadhead, right? This is the
Right.
stiffest part.
Yeah.
This is the part that's less stiff. Which part is going to be most strained by compressive forces? That is, if you're pushing on it, I've got this front part of my arrow. I'm including this part because
Yeah. The insert.
I don't
Yep.
know how long this insert is, but
Yep.
it's
Inch and
back
a half. Yep.
here. This is basically all solid, and it's not doing anything. So you imagine what's going on. You can sort of think about splitting the arrow into two parts. This part,
Yeah.
that's the
The knock.
shaft, and this part, that's, we'll just call it the front end.
Yeah.
Okay, the broadhead, whatever. Okay. And if you have a lot more mass in this part and a lot less mass in this part, what's going to happen when that hits something hard? Okay. So presuming the arrow doesn't break. So let's start with the arrow. It doesn't hit so hard that the arrow just actually shatters. But let's say the arrow doesn't break. What's going to happen? So the arrow is going to experience a uniform acceleration. That means that the front part of the arrow is not accelerating at a different rate than the back part of the arrow. If that were the case, if they were accelerating at different rates, then that means the arrow is broken because this part of the arrow is moving at a different velocity than this part of the arrow is.
Right. Right.
So for the arrow to stay in one piece means that the entire arrow experiences the same acceleration. Okay. Now, Newton's second law says that the force acting on a body is equal to its mass times its acceleration. And so what we have is that essentially, this is, and your viewers can go and watch this video if they want to see all the math actually laid out. But essentially what's happening is most of the mass is up here,
The front. Yeah.
and less of the mass is back here.
The rest.
And so most of the force that ends up acting on the arrow, because the acceleration for both parts A is the same. And if this part of the arrow has big mass and this part of the arrow has small mass, then the force felt by this part of the arrow is much, much larger than the force felt by this part of the arrow.
The rest of it. Gotcha.
So essentially, what you're effectively doing is concentrating the force of impact into the head and insert by having most of the mass of the arrow in the broadhead and in the insert. And the rest of the shaft doesn't feel as much force acting on it.
Okay. Yeah.
What does that mean? That means it's not having as much force acting on it. It's not going to bend and collapse as much. The more force that I push on the back of this thing, the harder I push on it, the more it's going to flex, right?
Yeah.
And so if I'm having less force acting on it, I'm getting less flex. On the other hand, if I have a very light broadhead, and that means the FOC is farther back here,
Yeah. Farther to the side.
that means there's less mass relatively in the broadhead and insert combination, and more of your total arrow mass is in the shaft. So again, basically what you're doing is you're distributing the total impact force. Less of it is getting used to decelerate the broadhead and the insert, and more of it is getting used to decelerate the shaft, because the shaft is now more massive. It's a larger percentage of the mass. So that means for the same impact force, you're going to have more force distributed on the shaft, and you're going to get more flexing. So it's not so much where is the FOC, it's what's the ratio of mass in the head to the mass in the rest of the shaft. That, of course, the larger the ratio here is, that's going to result in your FOC being farther.
Right.
Where the FOC does not show up in the equation. What shows up is how much of the mass is here and how much of the mass is here. The more the mass is here, the more of the impact force gets sort of absorbed by this part, and the less of it gets absorbed by this part. So if this goes into soft tissue, the impact forces are negligible. So who cares? Who cares if more of it gets pointed here or more of it gets pointed here? Your FOC is not going to make that big of a difference, because the impact forces are weak when you're going through soft tissue. right? There's just not much. Even with an example of a buffalo with really thick hide and fur and mud and all that kind of stuff, just going through that's not anywhere near as going through near as much force as going through a big chunk of heavy bone is. Okay, whether that's a scapula or whatever. Well, the edge of a scapula or whatever. So what does that mean? That means that, again, if you're going through soft tissue, really this is probably not going to make a big difference. And this is probably why, if you were to just go to a bunch of whitetail hunters, talk to them about the ideas of FOC, and try to convince them that having a 30% FOC arrow, they're going to get a lot better penetration than having a 10 or 12% FOC arrow. And they go, I get pass throughs all the time. I don't, what's your point? It's not really going to make that big of a difference, because in most cases, unless you just happen to be hitting shoulder bone, you've got bad shot placement, or the animal moves in a certain way where you're hitting something that you didn't mean to hit. In most cases, if you're having an ideal shot in a whitetail, there's just not enough stuff there to make a heavy impact. There's just not a lot of heavy forces. In other words, it doesn't matter how it hits, you're not going to get a big bending of your arrow when it hits a whitetail.
Right.
On the other hand, when you're shooting one of these giant Cape buffalo and you're shooting it into a rib that is basically, I think Ashby, he describes it in one of his write-ups. It's basically like the thickest part of an elk scapula is basically corresponds to what one of these trophy-sized buffalo ribs is like.
Oh, really?
So they're huge, and so those guys, when you hit those, you are hitting them with enough force that you're going to actually cause the arrow to start to flex. Now, if this thing hits, breaks through that bone, and starts to go through the soft tissue, if it's flexing like crazy as it's going through there, it's going to catch and it's going to slow it down.
Right.
So if you have a lot of force concentrated on the arrow, on the shaft, and it's causing it to flex like crazy after hitting something hard, then that flexing is actually going to slow it down. It's going to increase the forces acting on it, and it will reduce penetration.
Right.
The other hand, if you've got really high forward of center, meaning all your mass is up here and not very much of it's up here,
Yeah, a lot of front
it hits
weight.
that bone, it breaks the bone, but not a lot of the force gets transferred to the shaft. So the shaft is not flexing as much, and since it's not flexing as much, it's going to get deeper penetration because it's not sort of etching as it goes through there. I saw this on a video. I think it was Bomar, and several years ago. He put together an arrow system, like a 900 grain arrow system for a buffalo hunt or something.
Right.
And he was shooting it through YouTube, right? He was, for some reason, he was shooting it through a car hood, I think. Just
Okay. Yeah.
let's see what kind of craziness we can do to get viewers on YouTube, right? But what was interesting, when you looked at it, as it hit, he had a slow motion camera on the backside. As it hit this car hood and came through, the amount of flex that was happening in that arrow was insane. It was doing all kinds of crazy wobbling as it went through that car hood.
Right.
And that was my sort of hint that if you can do something that reduces that flexing as it goes through that bone and starts to penetrate into the soft tissue, you reduce that flexing, then that will result naturally in the arrow going further because there's just less force acting on it. So if you have a perfectly straight shaft and it's just falling, punches the hole open, and it just goes straight through without doing any kind of flexing, that's going to give you the maximum amount of penetration, as opposed to an arrow that's doing this as it goes through that. And I think that's what's going on with his studies in FOC, is that having all that weight concentrated up here basically reduce the flexing that happens in the back half of the shaft. And that results in things going further in. So then someone comes to me and says, well, do I need high FOC arrow for whitetail hunting? And I would say probably not, because you're not dealing with that. You're not punching an arrow through armor, that you would experience if you're hunting Cape buffalo. And so can I definitively say that having a high FOC arrow will not improve penetration and for something like whitetail? No, I can't definitively say that. I can say that the benefits are probably small, and that particularly for whitetail hunting, if your arrow system, if you're already getting a pass through on most of your encounters, and again, the times you don't get pass throughs are those weird times that we talked about earlier, where you've got some string jumping that happens strangely,
Yeah.
or you just made a poor shot and you hit a part of the animal you really shouldn't have. In barring those, if you are getting good penetration, then no, going to high FOC, you're probably just going to screw things up. Because what you certainly can't do is just unscrew this and put on a broadhead that weighs 50, 100 grains more, and then go take it and
No,
stick it in the same bow.
and
And
shoot
with
it.
doing some tuning without doing, you're probably going to have to change your arrow shaft. You
Yeah,
got to
your
do a
sight,
lot of
everything.
work. You got to do a lot of work to increase FOC significantly. And is it worth it for the average whitetail hunter? No, I don't think so. Is it worth it for someone who's hunting American buffalo, or certainly American buffalo or elk or something like that? I think that the benefits start to go up a little bit there, because you do have some thicker, heavier bones in there that you might hit on a higher occasion. Um, if you're going hunting in Africa, and you're particularly wanting to hunt with low energy bows like traditional equipment, and you know that you're going to be shooting Cape buffalo through in the rib cage. I mean, that's pretty much they're basically armored animals. They're just a much nastier thing to try to kill with an arrow than a whitetail deer. Yeah, I would encourage not to go crazy with FOC, but and I think his recommendation is 18% at a minimum. 18, 20, 25%. You want to build a special arrow for that kind of stuff. You just have to be aware that everything else can often become compounded when it comes to tuning, when it comes to making sure that you have good arrow trajectory, that all that stuff can become more complicated when you're trying to build. One thing, it's sometimes it's even hard to find arrows, like just to find the right spine, to find the right GPI. A
Yeah,
lot of these high FOC builds will tend to use arrows that have very, very low GPI,
yeah,
grains per inch, and what that means is that they tend to be very brittle, and so they break really easy, which is no good. That's not what you want to
yeah.
hunt buffalo. So there's a lot of compromises and trade-offs that people will sort of go to try to get some 25-30% FOC arrow. And I really don't recommend that for the average American archery hunter.
No,
I think that just sort of playing around in that middle range of 10% to 15% FOC. Honestly, just build an arrow that has decent broadhead weight. Use a really good broadhead. I would say 150 to 175 grain broadhead. The only reason I say that is because a lot of times the lighter broadheads, 100 grain broadheads, tend to have compromises made to make them that light. It's not that I think that the inherently a heavier broadhead is better. It's that the lighter broadheads I tend to think tend to be structurally less sound.
right.
And so they can
For
they can, they
fixed
can
blades,
break a
yeah,
little bit easier.
yeah,
So having just a little more material up there, it makes for a stronger broadhead. But trying to have something like 200 grains ish up front, and having a total arrow weight anywhere 450 to 550 for most American hunters, I think would be about an ideal system.
yeah,
Um,
definitely. One thing to
and
remember
it
too,
makes,
guys, about broadhead weight or front weight is it is reflected by the poundage you're shooting and your draw length. So one
yeah,
thing to keep in mind
yeah,
too.
yeah. And so I think that for me, that sort of 450 to 500 grain arrow, particularly for shooting compound bows, traditional, I would like to be a little bit heavier than that because we just have less energy.
Yeah,
And then the FOC will naturally come out unless you're shooting aluminum arrows. The FOC will naturally come out 10, 12, 15%, something like that in most cases. And don't worry about it from there.
yeah.
I don't think the most successful hunters in North America spend a lot of time measuring FOC on their arrows.
No,
It's
no.
not
That for me, that sweet spot too is between 450, 500. And it's for me, it's all about shot placement. It's just
Yeah, yeah,
where
yeah.
you put the
Well,
arrow.
again, all this physics stuff, that go back to the point that we had earlier, that there are a lot of variables outside of physics that are just for any individual shot are going to be larger factors for that particular individual shot. Shot placement is obviously the most important one. Yeah,
Yeah.
you miss the animal, you're definitely not killing it, right? So where you hit the animal is obviously the most important, but then probably fall closely behind that is how the animal happens to be moving when you hit them.
Yeah.
That's going to play a huge role in how much penetration you get or whether you get any penetration at all. And then somewhere down the line we get into the physics of it.
Yeah.
So what I like to think of it is that the physics of the system is sort of a way of pushing the odds in your favor,
Hmm.
that if you have an optimal setup, you are going to have fewer bad outcomes and
Hmm.
more desirable outcomes, but you are never going to guarantee yourself that you have all good outcomes.
Yeah.
That's not possible with archery. It's not even possible with rifle hunting.
Yeah.
So much less archery. I think that's something that we have to come to grips with as archers. And if that I know that that bothers some people morally, but it doesn't bother me. I mean, this is I don't, I think that to be ethical, we need to be as lethal as possible, but we also have to recognize that that archery as a system, an archery system, is not as lethal as some other systems out there. And because of that, you just have to recognize that occasionally you're going to have bad outcomes, and that doesn't bother me
Yeah.
personally, from a moral standpoint.
No. And I like one thing for me for shooting is what we talked about earlier is having a faster arrow, less things can go wrong.
Yeah,
The animals, if they're close enough, they're going to hear the arrow. If it gets there before they have time to react, they're not moving. And like we talked about earlier, there's less things that are, having outside forces on your arrow as it enters or where it hits on the animal.
yeah. It's again, that's a good point, because when you're whitetail hunting, you're particularly depending on what area of the country, of North America that you're doing whitetail hunting. Um, you know those, they could be the jumpiest animals.
Yeah.
They just move, they react, so their reaction times are so fast
Yeah.
that it really seems like it's a bad idea to intentionally hamper yourself with a really slow arrow, just to hit some FOC number.
Yeah.
That's not a good idea. On the other hand, you're hunting Cape buffalo or whatever.
Yeah.
All animals are fast, but I don't think anyone would make an argument that a big, heavy animal is going to accelerate and move and cause as many problems with string jumping as something like a whitetail or antelope or whatever is
Yeah.
going to. And so, yeah, you have to look at your particular situation, and I think that's one of the things that sort of bothers me a little bit with the Ashby people. Not that his data is bad, but they are taking data that, at least the last that I checked, all the published data was with these big, heavy, large animals. They're drawing conclusions on those things and then trying to tell people that that's what they needed to do things like hunt whitetail.
Yeah.
And that's just not logical. And it's not good advice. And I would strongly discourage anyone from just immediately saying, "Oh, I need to shoot a 725 grain arrow. It needs to be 28% FOC, and I'm just going to build that. That's going to be my system, and I'm going to go out and hunt, and that's going to be the most ethical thing for me."
Yeah.
And there's a good chance that it won't be. There's a good chance that could be a poor arrow for your system, particularly if you need to have some flexibility with range.
Yeah.
When you're a traditional hunter like me, you give up flexibility on range. My arrows are going way too slow, 150 feet per second. I can't shoot at an animal 45 yards away. That's
Right.
that's
Yeah.
extremely unethical for me to do that. you're got to, if you're Tim Gillingham and you're shooting in whatever 300, 305, 320 feet per second, whatever it is that he shoots, um, okay, you've got a lot more leeway on
Hmm.
how far you can be, and if that's what you need, that's what you need. And I think you can be ethical in either case, but you can't just start with an idea of this is what my system's going to be and then apply it to a case where it doesn't really apply and say, oh, I'm the most ethical person because I'm using this big heavy arrow.
Yeah.
Well, maybe you're not in that particular case because you're trying to do something with that big heavy arrow that it is not optimized to work with.
Yeah,
So,
and like arrow, we talked earlier too about trajectory. That makes a big difference. Some places you hunt, there's a lot of overhead cover, right? You need a nice flat flying
yep,
arrow. So
yep,
yeah, you're absolutely right. You gotta, it's all conducive to what you're hunting and where you're hunting. It plays a big role into your arrow selection.
yep, yep. So I think we've been on here for a couple of hours. So
Yeah, yeah,
I would like to talk about some other things, but maybe that's some things that we could pick up at a later date
yeah,
if
for
people are
sure.
very interested.
Yeah,
I do think some of the other things, the heavy bone threshold and whether or not your arrow has to be over 650 grains. Most people listening to this will probably recognize that I don't think that it's a great idea for everyone just to carte blanche shoot a 650 grain arrow. But we could talk about where that number comes from and why people make an argument for it. And potentially we could talk about some things like broadheads,
yeah,
mechanical versus traditional fixed blade heads,
definitely.
and then mechanical advantage, which has nothing to do with mechanical broadheads, but basically the how long versus how
Yeah,
wide your cut is,
cut
and why that might
penetration.
make a difference. So we can touch on some of the physics of those maybe if people are
Yeah,
interested.
let's do it too. And yeah, by then we should, most likely, I can guarantee we'll have a lot of questions and stuff and some comments. So yeah, that'd be fun. But I really appreciate your time. I know, you're a busy guy, so I do appreciate the 2 hours you spent with us. I'm not sure if I'm going to throw this all out in one episode or break it up into two.
Yep.
So I'll think about it. But thanks for your time. I'm gonna put links to all your stuff up in the show notes. So guys, just click those links and you're gonna, yeah, like I said, make sure you're not driving when you do it. Make sure you're sitting in front of the couch. It's a lot easier to watch and pay attention to the information when you're sitting on the couch rather than trying to watch it on your phone. Or, if you're on a 15-minute break at work, it's easier to dive into and really absorb it all when you're comfortable. So, but I appreciate your time and the information, man. And I have so much fun talking about this stuff. When it comes to archery, I'm just such a geek. I love
Yeah.
all the ins and outs of it. So, thanks again.
No worries. I'll give you a couple of pro tips for your listeners. If you do go watch those videos, and they're not for everyone, but if you do want to go watch those videos, speed them up. Do 1.25x. You can still follow along with me, but I'm a little slow talker sometimes, so that speeds it up a little bit. But yeah, don't. It's not really one to listen to in your car ride. You kind of have to sit down. It's a physics course.
Yeah,
So
cool
um,
stuff though, man.
Yep. And
Appreciate it.
also I try to answer comments on those videos.
Okay.
So if anyone has questions, they can throw those questions into the comments, and I'll answer them the way as best as I can in that format. But I also will probably start keeping a record of what questions I get on there, if any, and that might be something that we could talk about in the future too.
Yeah, and you're really good on Instagram too for getting back to people. So again, your Instagram link is up in show notes. So just get a hold of him through Instagram. I know that's how I did. He got back to me right away. So appreciate your time, Jared. Always fun. And yeah, let's do this again. Until next time. Bye, everybody.
Good. Thanks.